Hello students, welcome to today's lesson, that is lesson 3 of circle theorem. Good. So the last time we met, we looked at one of the theorems, that is the first theorem concerning the diameter, and we solved some examples. Now before we start today's lesson, I would like you to try this one for me before we move on. So the question is, find the value of x. Find the value of x in the diagram below. Find the value of x in the diagram below. So let's look at our diagram. So this is our diagram. So A, B, C, and D, where this one too is our center. Good. So try your hands on this one before we move to our lesson for today. So I'm giving you 2 minutes. 2 minutes to try your hands on this one. 2 minutes. Okay, so we'll solve this one and then we'll move on to our lesson for today. So let's look at the solution. Good. So we are to solve for x. We are to solve for x. Now, from the diagram, O is the center, or from the question, O is the center of the circle. So if O is the center of the circle, then it means that line AC is a diameter. and from the theorem that we learned, angle ABC, that is this angle, will be 90 degrees. So from plane geometry 1, we can find x in two ways. One way is by adding this angle to this angle and getting it. That is adding these two interior angles of the triangle to get the exterior angle. Or we can find this third angle here at C. Then we subtract our answer from 180 to get x. That is angle on a straight line. So using angle on a straight line, we can subtract the angle here from 180 to get our x. Okay, so let's try the shorter one so that next time you at your own convenience you do the longer one. So we are going to use the plane geometry concept that the sum of two interior opposite angles will give us what? An exterior angle. So let's see. So it means that angle BAO plus angle ABC should give us x. So substituting, angle BAO is 15 degrees from the question, and then angle ABC is 90 degrees from the theorem. So now our x will be equal to 15 degrees plus 90 degrees, and which will give us 105 degrees. So our x is equal to 105 degrees. So that is the answer to this question. So now let's move on to our topic for today. So we are going to look at the second theorem. Our second theorem. So theorem 2. Now let's look at what the theorem is about. So it says that when you have a circle, okay, and then you have a chord. So this is a chord. Let's label it AB. So the theorem is saying that if you have a chord inside a circle and then you have a center here, now the angle that the chord forms at the center, which is this angle, okay, the angle that the chord forms at the center and the angle that the same chord forms at the circumference of the circle, they are related in this way. So let's look at that. So this is C. So the theorem is saying that this angle at this center formed by the chord AB. So this chord AB formed this angle. Okay, the angle here, this angle here was formed from chord AB. And then the same chord AB formed this angle here at C. Okay, formed this angle here at C. So the relationship is that if this angle here, if the angle at the circumference here formed by the chord is x, then the one at the bottom will be 2x. So what it means is that the angle formed at the center here by the chord is twice the angle formed at the circumference. is twice the angle formed at the circumference. So if a chord forms an angle at the center and the same chord forms an angle at the circumference, the angle formed at the center is twice the angle formed at the circumference. Is that clear? So let's go over. It says that if a chord forms an angle at the center and the same chord forms an angle at the circumference, then the angle formed at the center is twice the angle formed at the circumference. Is twice the angle formed at the circumference. So let's state the theorem. So it states that if a chord forms an angle at the center, so if a chord forms an angle at the center, let me erase. If a chord forms an angle, let's go back. Look, if a chord forms an angle at the center and the same chord forms an angle at the circumference, then the angle at the center is twice the angle at the circumference. Good. So if a chord forms an angle at the center and the same chord forms an angle at the circumference, then the angle at the center is twice the angle at the circumference. So it means that angle AOC is equal to 2 times angle A, so this is B. So angle AOB is equal to 2 times angle ACB. Okay, so angle AOB is equal to 2 times angle ACB. So this is angle AOB, so the center is O. Okay, so angle AOB is 2 times angle what? ACB. Is 2 times angle ACB. So this is the second theorem. So the angle formed at the center is twice the angle formed at the circumference. The angle formed at the center by a chord is twice the angle formed at the circumference by the same chord. So I hope that is clear. So now let's look at an example. Let's take an example. So example. So this will be example 1 under the example 1 under the second theorem. Example 1 under the second theorem. So let's look at this one. Find the value of x in the diagram below. Find the value of x in the diagram below. So let's look at the diagram. Good. So now let's look at the solution. So we have to find the value of x in the diagram below. So mind you, in this diagram, O is the center. Now you should be aware with this circuit theorem questions, if the O is not made the center, you don't assume it's the center. So if you see a point at the center of a circle, don't assume that is the center until the question tells you that what it is the center. Okay, so I'll add it next time. So always make sure that in the question it is stated that O or E or Z is the center of the circle. Don't assume. Good. We don't assume here. Good. So now let's look at the solution. Good. So from the second theorem, we can identify a chord. We can identify a chord which is AC. Now from the diagram, chord AC formed the 100 degrees at the center O, and then the same chord AC formed the angle X at B. The angle X at B. So once we are able to identify this chord and we know the relationship between this angle and this angle formed by the same chord, we put that relation down, we substitute, then we simplify. So the relation between this angle and this angle, based on the fact that they were all formed from the same chord, is that, let's see, angle AOC is equal to what? 2 times angle ABC. So angle AOC is 2 times angle ABC. So we have to solve for what? Angle ABC, which is what? The X. So substituting, it means that we are going to have 100 degrees is equal to 2x. 100 degrees is equal to 2x. So making x the subject, that is dividing both sides by 2. Okay. Our x will be equal to what? 50 degrees. So this goes here, one goes there, 50. Okay. So angle AOC equals 2 times angle ABC. Now when we substitute, we have 100 degrees equals 2x. So cancelling both sides by 2x, we have our x to be equal to what? 50 degrees. Our x to be equal to 50 degrees. Good. So let's look at our another example, but that one you are going to do it. You are going to do it.